How would you think about the underlying infrastructure when building agents?
So, two big shifts here, right? And the first I want to touch on is on inference. We've moved past just, build a bigger model and let it do everything. The frontier now is giving the model compute time at inference. And it is what we call the test time, or let me say, thinking compute. And for instance, if you take something like, Gemini 3, which is Google's model, for instance, it has a thinking budget. And what does that mean? It means that it can spend before answering. So your own example that you give it, instead of letting this LLM think or guessing the answer through a hard math or like a coding problem in 2 seconds, an agent has the capability to actually write a Python script. It can actually execute it in a sandbox, read an error log, fix its own code, and returns a verified answer to you. So it deliberately trades raw throughput and token for far higher accuracy. And from the infrastructure standpoint, that actually changes everything, right? That allows for longer running sessions, more tokens per task, higher latency tolerance, and hard requirements for sandbox code execution, right? So at the inference layer, this is how it ties in when it comes to agents. And the second thing that I want to also highlight here is matching compute to the workload. And the key insight for builders is that, not every step of an agent actually needs a GPU or a graphic processing unit, right? The orchestration, the tool calls, the glue logic that runs an agent can actually run on a normal CPU, right, without having any issues. And you actually would have to reach for accelerated compute, which is a GPU or a TPU at the model inference layer, right? And the type of accelerator actually depends on the job that this agent is doing. So, for example, if you are building agents like agents that handle drug discovery and simulation use cases, these kinds of agents require high throughput, high bandwidth GPUs with strong parallel processing and sometimes ray tracing capabilities. And that is where something like RG4 GPUs with the NVIDIA RTX Pro 6000 comes in, right? If you talk about agents that handles only text or what we call the LLM agents, they often do not need that profile at all, right? They simply call like a managed model API and then let Google handle whatever is underneath that. And then we also have CPU versus accelerated compute, right? And this is actually the what I call is the first fork because TPUs are actually for high throughput. So for example, is what we use for serving Gemini. And then the GPU portfolio also works with partners, open, and even specialized workloads that we have on top of on top of Google Cloud. So the mental model that I actually leave people with here is that an agent isn't actually one process that you size for. It is actually a distributed system. When you build one, you're actually provisioning, serving, and a memory state store and two sandboxes and the network between agents. And the underlying infrastructure will depend on the specific use case that you're building it for.
Oh, that's great. And it's so true. There's so many different types of underlying compute that you can match up to the type of the agent from using our standard compute, workload optimized, or even if you need to get that accelerated computing, we have a whole wide range of portfolio of options to help with the accelerated side as well. What are the different types of deployment methods and how do you choose between them?
The easy way for choosing which deployment pattern is Cloud Run. Use that for serverless speed. Use the agent runtime for a managed enterprise runtime with memory and governance. And Use the GKE agent sandbox for secure coding execution at maximum scale and control.
Mhm. Those are excellent points. And with Cloud Run, you were just making me think of Able. They build their agents entirely on Cloud Run, and they just moved from the L2 GPU to our G4 instance, which is the RTX 6000 Server Pro Edition, NVIDIA's GPU.